Hey, it's Dr. J. Finishing section 6.2 today. This will be part 2. General percent applications. Today I'm going to focus on percent increase or decrease. Well, I'm actually going to do both, but it's each problem is either one or the other. So before I actually do any problems from the book or from the homework, I'm just going to talk a little bit about the idea. Suppose an item, we'll talk about money. It's probably the most common way to think about it, but it doesn't have to be an item. It could be any quantity. Or anything. Well, it doesn't really have to be a thing either, but that's neither here nor there. Suppose it has a cost of, I don't know, $5. Okay? And then the price goes up. To $6. Yeah? And you might think, well, that's a $1 increase. Yeah? But how much is it increasing percentage-wise? Right. You wouldn't say 1%. Yeah? The percent of increase is that $1. Yeah, that's that original dollar that it increased, divided by how much it originally cost. So we all base this on what's called the original, whatever it is. In this problem, it's cost, but it doesn't have to be cost. It could be any quantity. Dollars are a convenient thing to think about because we deal with this all the time. And so this would be your percent increase written as a fraction. Yeah? But to turn it into a percent, you would multiply by 100%. So 1/5 is 0.2. Right? You might want to have your calculator handy. I could do 1/5 in my head, 0.2, but they might get them a little more complicated. So on a calculator, 1 divided by 5 is 0.2 or 2/10 times 100%. I'm using the old-fashioned X for times today, although you could just use parentheses. And so that would be 20% increase. So that's the idea behind percent increase. You look at how much it actually increases. That's the quantity. You put that in the numerator. And then you always divide it by the original amount. All right, how much was it when this whole process started? So I could take this example to another level. I could say, well, suppose the item originally cost $20 and I raised it to $21. That's still a $1 increase. Yeah, it's still only going up by $1 from 20 to 21. And so to find the percent increase, it would be the same process, but you'd be dividing by 20 this time. So when you talk about something increasing, or in a minute I'll talk about decreasing, but to kind of get it going, I'm talking about increasing. You're always comparing it to what it used to be. So you think back, well, the original amount. And then the other amount, we call this the new amount or the current amount. I get really tired of writing current, so I sometimes will just call it new. And then I hope nobody is offended, but original we're now going to call old. I know some people don't like to be called old. They would rather be called original. Yeah. So I'm just going to call them new and old because it's just a lot easier to write the words new and old than it is to original. So in this case, if something started at $20 and went up to $21, the increase is still only $1, but you have to compare that dollar to its original price, which was $20, and so now that's a nickel. Yeah, 1 out of 20, 1 divided by 20. Again, if you need the calculator, you've got it. 1 divided by 20, and there it is, a nickel, times 100% is 5%. Typically in this lecture, I will be doing this part mentally. So when I say multiply by 100%, I'm not actually going to multiply by 100%. I'm just going to do it in my mind. When you multiply something by 100%, you move the decimal 2 places to the right. Okay, so that's typically done here by just using the techniques that we saw in 6.1. Okay. All right, that's the idea. Now you might not want to have to, piece this together every time on your own. So we have a formula for percent increase. It's the new amount minus the old amount divided by the old amount times 100%. So that's your formula for percent increase. Okay, so an example. Suppose the old amount is, I don't know why I'm using a colon here. I think that's what it is in the book. I'm just going to use an equal sign. The colon can be a little misleading. I might go and actually modify that a little bit. So suppose the old amount was 80, also known as the original, and the new amount is 120. Find the percent increase. So we just use this recipe. New is 120 minus old, which is 80, always dividing by old, and then times 100%. Again, I'll put this in a little cloud bubble here. I don't recommend actually multiplying by 100%. I mean just mentally move the decimal 2 places and turn it into a percent. So 20 minus 80 is 40 over 80 times 100%, which is 1/2 times 100%. Or if you prefer, I actually do prefer decimals. So 40 divided by 80, I don't really need the calculator for that, but 40 divided by 80 is 1/2, but it's probably better to write it as a decimal, 0.5. And then again, you're going to do this part mentally. To multiply by 100%, you're going to move the decimal 2 places to the right. And so you have a 50% increase. Okay, so that's the formula for percent increase. Well, prices or things, doesn't have to be a price, but objects, items, values often go down, right? So that would be percent decrease. Now, percent decrease is the same formula. You just reverse the numerator. So it's old minus new. You do not change the denominator, though. You just reverse the order of the numerator. So instead of new minus old, if it's a decrease, something's going down, then you do old minus new. So suppose the old or the original is 150, and the new amount or the current amount is 120. So notice it originally was 150, but now it's gone down to 120. And so the percent decrease is old minus new. So old is 150. That's old, original. Minus 120. But remember, you're always dividing by the old, the original. And then times 100%. Uh, 30 divided by 50, I think, is 30 divided by 150 is 0.2. You always want to write that as a decimal. And then multiply by 100%, which really just means move the decimal over 2 places. So you get 20%. And that is a decrease. Now, this always drove me crazy, having to memorize 2 formulas for one concept. So you have the option. I mean, I gave you both formulas. There's a formula for decrease and there's a formula for increase. And if you look these up on the internet, you're going to see the same formulas. Sometimes they use variables instead of the words. And there's other, terminologies for how to calculate the percentage. Some people use the decimal form of 100%, which is 0.01. So there's lots of different presentations of these formulas, but they're all essentially the same formula. Now here's what I like to do. Before I do any more problems, let's just talk about the 2 different formulas. So let me just use the symbol percent increase. That is new minus old over old times 100%. Okay, versus percent decrease, which is old minus new divided by old times 100%. So let's talk a little bit about these 2 formulas and see what we can do to compare the 2 and maybe come up with just one formula that will do the job for us. Okay. So the reason why we have 2 formulas is because we want to avoid negative numbers. In the traditional version of this course, the way it was taught maybe 5 or 10 years ago, or maybe even longer, but I can say from personal experience, I taught this class 5 or 10 years ago, we didn't teach negative numbers so soon, right? That was the old way to do it. And in the last 5 or 10 years, we've been teaching negative numbers a lot sooner, but if you would have taken this class with me in the 90s or even in the early 2000s, I probably wouldn't have done negative numbers yet. It would be something we do way towards literally like right before the final exams, like, oh, we're going to do negative numbers. And you basically would, get sent off to your next class with a very, very rough understanding of negative numbers, and you'd have to suffer through the negative numbers in the next class. And so we kind of decided, over the course of 5 or 10 years to introduce the negative numbers sooner. But when these formulas were first developed, they're developed for the public consumption, and, the idea of using negative numbers just seemed, confusing, right? We didn't want to confuse people with negative numbers. So we're trying to avoid the negative numbers. And so that's the reason why we have the 2 different formulas, right? And so suppose you've got the new amount is, 35, and the old amount was, I don't know, 40. All right? Suppose that's the case. I'm not going to call this example 3 yet. I'm just going to sort of talk about these two formulas, right? So suppose you take this formula and you actually use the wrong formula, right? Suppose you use this one, right? Incorrectly. You notice that the new amount is 35, the old amount is 40. It's actually gone down, right? If something used to cost 40, or if there used to be 40, whatever that means, $40, 40 people, whatever, and now there's only 35, that means the number has actually gone down. So I should be using this formula, right? But it's very common to just grab the wrong formula, right? I'm guilty of that, right? Because I just want to memorize this one formula. I don't want to have 2 different formulas. Well, what would happen, right? Let's see what would happen. New minus old would be 35 minus 40 over 40 times 100%, of course. 35 minus 40 is negative 5, which is what we were trying to avoid. We didn't really want that to happen. All right. Especially if you hadn't learned about negative numbers yet. I mean, if this would have happened, when I taught this class 5 years ago, the students would have been like, wait a minute, you haven't taught us about negative numbers yet. Why are you? But I already have taught you guys about negative numbers, so I'm not really concerned with avoiding them. I mean, I think it's important that you understand negative numbers. It's one of the main objectives of the course now. Times 100%. And so now I've got negative 5 divided by 40, which I should probably just do this by hand, but I'm not going to. I know that most people are going to use a calculator, and you know how it makes my lectures go a lot faster if I use the calculator. So negative 5 divided by 40 is negative 1/8, which is 0.125, times 100%. And so that's negative 12.5%. And so if you type negative 12.5%, the computer will actually mark it wrong because we want to avoid negative numbers. But what I'm telling you is that that's okay. You can just forget about this formula and just use the same formula for both. If the result is negative, remove the negative sign, or ignore it, and call it a decrease. So you don't say it decreased by negative 12.5. And you also don't say it increased by negative 12.5. What you do is you say percent decrease of 12.5. So you just remove the negative sign and call it a decrease. So you say it's a percent decrease of 12.5%. So the negative sign is literally translating into the word decrease. All right. If you get a positive result, then say increase. Yeah, and give the value as is. Yeah. Because if you get a positive result, then that means it is what it is, right? It is an increase. It's a positive amount. Okay. And now the great thing about this is no longer do you need 2 formulas. Now you only need 1 formula. And I've just lightened your load. Buy one, get one free. You really only need this one formula. And then you just take this value. If this value comes out to be positive, then you call it an increase. If this value comes out to be negative, then you call it a decrease. I don't know if you can read that. Decrease. Okay. So students from 10 years ago needed to memorize 2 formulas, or even just 5 years ago. We changed this class. We changed the book and the course description about 5 years ago. And so now we teach the negative numbers a lot earlier. You learned them way back in chapter 2. And so now you can have only one formula. Okay? So now we can do the rest of the examples, and I don't have to constantly switch back and forth between the 2 different formulas. I'm just going to use this formula. It's always new minus old divided by old. Yeah, new minus old divided by old. All right, example 3. Determine if there is an increase or decrease, and find the percentage. I'm just going to write the word. And by the way, when I say find the percent, I mean the percent of increase or decrease, obviously. That's all we're talking about today. So suppose the original amount was 90, and the new amount is 100. All right, so you got new minus old over old times 100%. The new is 100 minus the old is 90 over the old, which is 90. Okay, 100 minus 90 is 10 over 90. So you know that this is an increase. You could have actually seen that here too. Right? It's going from 90 to 100, so that's an increase. 10 divided by 90 is probably going to be a repeating decimal, right? You already know it. It's 0.111111111. Right. It's the same as 1/9. Yeah. 10 divided by 90. So that would be, I'm just going to put the answer up here. That would be 11.1%. Yeah, so I'm going to round to the nearest tenth. So tenth is 1 decimal place. That's pretty common in this section. I don't think there's any that go to the 100th. Oh, I think there are a couple that go to the 100th. So we'll have to read carefully. In this one, I'm doing the 10th. 11.1%. Remember, the decimal is here, and I'm moving it 2 places to the right, so that's 11.1. Okay? Now watch why this is important. You might think, well, of course I knew that was an increase, right? But there's some tricky problems out there, and that's the whole reason why I'm giving this example. Sometimes I like to give you what appears to be the same problem. You've probably gotten to know me by now, right? It's been several months. I'll give you a problem that looks almost like the same problem you just had, right? It looks exactly like the same problem. Yeah. But this time it's a decrease. But I'm not going to change the formula. I'm still going to do new minus old over old, right? Remember, old always goes in the bottom. Yeah, so it's new minus old over old. So it's 90 minus 100 over 100, not over 90. Last time it was, the old was 90. So this time it's negative 10 over 100, of course, times 100%. I left that out a second ago. That's also up here. I like to just put that in a little cloud. It's kind of a don't forget to multiply by 100%. So that's negative 1/10. This one does not repeat because you're dividing by 100 times 100%, which is negative 10%. Now again, don't type the negative sign. Ignore the negative sign and just say percent decrease of 10%. So the negative sign literally becomes the word decrease, going down. Which, by the way, that's what a negative sign means, right? I mean, it's kind of always meant that, right? If something goes down, it's decreasing, it's subtracting, right? It's minus, it's going down. Yeah? If something's increasing, it's positive, it's going up, right? So this fits right in with our understanding of positive and negative numbers anyway. Now, the reason why we don't put the negative is because it would be redundant. To say a decrease of negative 10%, that would be redundant because decrease already means negative. Yeah. Another reason is this type of information is meant for the average viewer, the average consumer, and so we typically don't like to put negative numbers in things like, advertisements and publications and news stories, and they want to say, the population is decreasing, and then they don't want to say negative number. They want to say decreasing 10%. And then everybody goes, oh, okay, I understand what 10% is. Even if they don't really understand what that means. It kind of sounds like they might understand what it means. Okay? So that's the idea. And so you only need one formula, new minus old over old, and then just pay attention to whether it comes out to be negative or positive. There are other types of roundings. You might round to the nearest whole percent. So in 1980, the average salary of a teacher in California was $25,000 per year. By the year 2000, that number had grown to $55,000 per year. Find the percent increase and round to the nearest whole. Or whole percent, I guess. I'm finding a percent increase. Now in this one, I kind of gave it away. I told you it was an increase. I think that's kind of obvious. Look, back in 1980, teachers were making $25,000, so that's the old amount. And then the new amount is $55,000. Now, by the way, I'm calling that new. It's new if you lived in the year 2000. We'd have to do some research to find the 2020 version of this number, but I didn't want to, ruin it for anybody, so I just decided to keep some old numbers here from 1980 to 2000. So, and now you can ignore the years, because the years are really just to tell you who's old and who's new. All right, you're not going to use them in the actual formula. And then remember, it's always new minus old over old. That's the main mistake that students will often make. In fact, I've made that mistake. Just be going too fast and you go new minus old, and then you accidentally divide by the new, which is one of the reasons why I label them. All right. Okay. Now this should come out to be positive because I set it up correctly. If it accidentally came out to be negative, then I would read the question again and go, wait a minute, it can't be negative, right? It's got to be positive because it's an increase. 55,000 minus 25,000 is 30,000, right? If you have to use the calculator to make sure you don't make a mistake, 55,000 minus 25,000. Now I feel stupid. That's definitely 30,000 over 25,000. Again, times 100% mentally. So I got 30,000 divided by 25,000. That's 1.2 times 100%. That's 120%. Remember from, and that's a percent increase. Remember from 6.1, if the decimal is more than 1, then that means the percentage is more than 100. Real easy way to think about it is 100% means that the price has doubled, right? Or whatever it is. In this case, it's salary. So the salary more than doubled. 25,000 all the way to 55,000. It's a little bit more than double. So that's 120% increase. And that's the kind of thing that you'd read about in a report or an article or something. Salaries of teachers have increased by 120% over 20 years. So it makes it sound like, oh yeah, we're doing a great job. Now the one thing they don't include in a problem like this, well, the costs of housing has gone up, the costs of food and clothes and cars and gas and everything else has gone up too. So that's something for an economics class and not for a pre-algebra class. Here I'm just concerned with getting the right answer, and I'm not too concerned with the inner workings of economics and society. Okay. You might be, but this certainly gives you some insight into how that works. Okay, I got more of these. Example 6. Maybe I'll be less revealing in some of the other examples. Come on back to me. Let's see. In 1963, there were approximately 15,000 wild bighorn. These are the sheep that live in our mountains in the Coachella Valley. Now, when I say the Coachella Valley, I mean the extended Coachella Valley, like including all the mountains and stuff around the valley. Okay, I don't feel like writing all of that, so blah 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 blah. Okay. By 1994, the number was estimated to be 8,000. So determine if it's an increase or decrease. You can probably tell right now by reading it. And find the percentage. Okay, of such, of whatever it happens to be. So I think you can probably tell right now, 1963, that's the old amount. So I can cross out the year. I don't really need it anymore. That is 15,000. And then the new amount is 8,000, and I don't need the 1994. And again, when I say new, it doesn't really mean 2020 new. It means newest, the newest one in the given problem that we happen to be doing. All right. So you can already tell right now it's going to be a decrease, right? There used to be 15,000. Now there's, or at least in 1994, there was only 8,000. All right. So we got new, 8,000 minus 15,000 over old. Remember, you always want to divide by the old amount, 15,000. So that's negative 7,000 divided by 15,000. And again, I don't want to leave this part out, that times 100%. I know I left it out over here, but so this is what tells you it's a decrease. Determine if it's an increase or a decrease. So if you didn't catch it, it's almost like you have a safety net. If you didn't notice it when you're reading the problem, because oftentimes you'll read a problem, you'll start solving the problem, and you might not notice something. So if you didn't notice it a minute ago, you're definitely going to notice it now. It's negative 7,000. All right, so we got 7,000 divided by 15,000, which if you want, you can just divide 7 divided by 15, right? Because they're both thousands. They both have 3 zeros. And for this one, I want you to round to the nearest whole percent. I'll tell you in each problem. Did I do that in the last one? Did I do whole percent? No, I feel like I didn't follow the directions in the last one. Yeah, I did. It was 120%, right? Yeah, that was whole. Whew. Had me worried for a minute. This one's definitely not whole. This is 0.4666666 forever and ever. Repeating decimal. I could just put a bar over it, like that or something. I'm not really doing that today. So that would be 46.7. Rounding to the nearest whole would be 47%, and we would ignore the negative sign. Right? Technically, this is negative for 46.7. Yeah, but that's just the decrease symbol. We're going to just cross that off, and we're going to say decreasing of 47%, or decrease by 47%. Decreased or decrease. I'm not really too concerned with the plurality or the past present tense of the word. Just it went down 47%. Okay. How about gas? Gas goes up and down, right? It really depends. So last week, the average price of a gallon of gas now there's lots of different types of gas. I'm just assuming the cheapest one was $3.75.09. This week, the average price is $3.45.09. All right, so determine if there was an increase or decrease. Find the amount of increase or decrease, and find the percentage. I guess I got two different ways to round. Let's say round to two decimal places. And again, every problem, I don't want to say every problem has a different rounding, but you'll get in the habit of doing it one way, and then all of a sudden you'll hit a problem that has you do it a different way. So I'm just trying to give you all the different varieties. It's usually whole number, tenth, which is one decimal, or two decimals. Those are the three most common ones. A little fun fact about gas prices. Gas is one of the only products in the United States that can sell their product, in particular gas, for less than a penny. Yeah. So 9/10 of a cent, 9/10 of 1 cent is equal to 0.009. All right. It's 1,000th of a dollar. Right? It's actually 9 1,000ths of $1. Right? 9 1,000ths of a dollar. It comes from the 1930s, when the very first gas tax was introduced. Prior to the 1930s, there was no tax on gas. So if gas costs, 5 cents, then gas costs 5 cents, right? And so the federal government wanted to add a 1 cent gas tax. And so if you're a gas station, you don't want to advertise 5-cent gas, right? So come to my gas station. It's only 5 cents a gallon, right? And then when you go and pump your gas, they say, oh, but it's actually 6 cents because there's a 1 cent gas tax. And so in the 1930s, the gas was only 5 cents. They would say 5 9/10 cents because it made, and this is cents, not dollars. This is cents. And so they would put it on the sign that gas was 5 9/10 cents. And that was the 9/10 was to pay that extra gas tax, without really letting this person know that they were actually paying 6 cents a gallon, because this looks like 5 cents when it's actually 6 cents, right? 5 and 9, because by the way, they always round up, right? Because you can't actually, when you go up there with your money, you can't pay 9/10 of a cent. So if the price of something costs 9/10 of a cent, then you're actually going to have to pay the whole cent, right? They don't round down, they always round up. Yeah, 9 rounds up to a whole cent. So this is actually 6 cents. Yeah, 5 and 9/10 cents. And so this tradition has been going on since the 1930s, where gas stations add the 9/10 of a cent to make it look as if this gas is $3.75. But in reality, if you were to go buy 1 gallon, you wouldn't pay $3.75. You would pay $3.76 because that 9/10 would round that up. Okay. And the same thing goes for the other price, right? So when you do a math problem involving gas prices, most math books, including my own, or it's not my book, but it's the book we're using, just omit the 9/10 right away, just to kind of avoid the confusion. I decided to keep it in because I noticed that, I was pumping gas just the other day and I noticed it and I'm like, oh, that would make a pretty good math problem, right? So first of all, we're going to rewrite these. So what's the old? The old was last week, so that's the old. And then this week is the new. So make sure you know who old and new is. And then write them like this. 3759. That's the old. So the 9/10 just becomes the 3rd decimal place. I would not recommend leaving it as 9/10. I would just write it as an extra 9 on there. All right. And then the new is 3459. And I think on the fancy digital screens that they have on the gas pumps now, they actually do show that 9 there now. But when you're driving down the road, it looks like a fraction 9/10, because it's on the big sign there. Okay, so first of all, is this an increase or a decrease? This is a decrease. Yeah. You can tell because the new minus the old is negative. 3.459 minus 3.759 is negative 0.3. So that's a decrease. The amount of decrease is 0.3, or 30 cents. If you want to write it as dollars and cents, it's $0.30. I would also just accept 0.3. But some people like to see it as cents. All right, we typically round to 2 decimal places, so I'm putting 3 and then a 0, which means the same thing as 0.3. All right. I'll squeeze a little equal sign in there. Don't worry, the dollar sign will already be there for you. Now, this is not the percent of decrease. Did I say increase? You know what I meant. Decrease. This is not the percent of decrease. This is the amount of decrease. The percent of decrease is 0.3 divided by the old times 100%. All right, you could do this all on your calculator. So 0.3, or if you prefer 0.30 divided by 3.759 is, where do I write it? I'm going to write it here. 0.0798 times 100%. So I got to move the decimal 2 places. That is 7.98%. All right, I'm just going to do it mentally here. The decimal point is right here. There's your 100%. So move it 2 places to the right and then round it to the nearest 2 decimal places. Or whatever it says. If it says 2, then do 2. If it says 1, then do 1. If it says whole, then I would just round that up to 8. It'd be 8%. So, read it carefully. I have been guilty myself of getting a problem wrong simply because I didn't read it correctly. So just keep that in mind. All right, I guess I got time for one more. It doesn't always have to be a price. I think I got one more if the camera will cooperate with me. Come on back. Come on back. There we go. Before going on a diet, Dr. Jordan weighed 200 pounds. After 3 months, I'm using myself as an example here, he weighed 180 pounds. I'm kind of giving it away, yeah. Is it an increase or a decrease? Sometimes I'm not so subtle with these things, yeah. So I kind of gave it away before going on a diet. It'd be funny if I went on the diet and actually gained weight. Weighed 200 pounds. So that's the old amount, yeah. The new amount is 180, and so that is a decrease. Yeah, so I know it's a decrease. Check. It's a diet. I'm supposed to lose weight, right? What is the amount of decrease? Well, just use mental math, right? 20 pounds. 200 pounds to 180 pounds. You don't always need a formula for everything. Yeah. What's the percent of decrease? 20 pounds divided by the old amount, which is 200 pounds. That's 1/10. Yeah, 20 divided by 200 is 1/10 times 100%. Is a 10% decrease. So this is the kind of problem that really I didn't break out the calculator. I didn't write out the entire formula. This is the way that you would want to do a problem like this mentally. It doesn't have to be these types of numbers, but usually it's funny, we call these round numbers. I don't know who came up with that term, but these are nice round numbers. And so typically when you're calculating mentally with nice round numbers, you can do rough calculations like that and then pop out the answer very quickly. Makes you sound very intelligent, makes you have a good sense of the way the world works. If you're in business or you're interested in going into business, this is the way you want to be able to calculate things very quickly and very, very efficiently, no matter what the values happen to be. Of course, as the numbers get larger, or sometimes if they get really small decimals, you might need to use your calculator occasionally. But I just wanted to end with not every problem has to be a problem. Okay. I thought I'd use my self-deprecating example here. Maybe when you do your homework, you'll find out that things have changed. Maybe a decrease turns into an increase, or vice versa. Not everything that goes down goes back up, but one thing is true: everything that goes up must come back down. Well, I guess that'll do it. Until we meet again, this is Dr. Jordan. I'll see you on the internet.